Hello AP Calc students. Today we're going to go over how to find limits at infinity and also talk about some asymptotes. We got vertical asymptotes and horizontal asymptotes. And of course we've seen these before in Algebra 2 and pre-calculus, but now we can define asymptotes with calculus, with limits. First off, we got our definition here of vertical asymptotes. So vertical asymptotes happen at x equals c if either the limit as x goes to c from the left-hand side, that's what this little minus sign here means, from the left of a function is equal to either positive infinity or negative infinity, or the limit as x goes to c from the right of some function is equal to positive or negative infinity. So let's take a quick example of what this looks like on a graph. So say we have our coordinates here. We got our x-axis, we got our y-axis, and maybe we have an asymptote. So an asymptote we usually show with a dashed line, and we have some function, and that function is going to act as an asymptote when that function as it approaches. It either goes down to negative infinity or it goes up to positive infinity. So usually we see it go like this, where one side goes down to negative infinity and another side goes up to positive infinity. So in this case, we would say that the limit of x as it goes to, and let's just say that this is here x equals 3, we would have our asymptote here at x equals 3. So the limit as x goes to 3 of this function, well, first off, if we take the limit, it does not exist. But if we go from the left-hand side, then we'd have the limit going to negative infinity. And if we take the limit as x goes to 3 from the right-hand side, we'd have that the limit is positive infinity. So there we can see it acts as an asymptote. Let me show you one more example, because an asymptote, a vertical asymptote, it doesn't have to be two-sided like that. We could have a vertical asymptote just on one side. So what could happen, draw my dashed line here, and imagine that you have a function, and maybe on one side it goes up like this, but on the other side maybe it actually is on the asymptote, or it could be an open circle or closed circle there, and it could do something like that. That's still an asymptote, although it only acts on one side, because here we have the limit as x gets closer to, let's just say that this is at 4. So the limit as x gets to 4 from the left-hand side of this function is equal to infinity. But from the right-hand side, it would have a limit. But either way, it still is a vertical asymptote. So that's a vertical asymptote. Usually restriction on domain. Usually comes from rational functions, although this one over here is probably from a piecewise function. We can also have horizontal asymptotes. So horizontal asymptotes occur when x is equal to L if either the limit as we go to negative infinity is equal to some finite number L, or the limit as we go to positive infinity is equal to some limit. So here again, let's take a look at a graphical example. This definition also means we could have two horizontal asymptotes. So we could have an asymptote as we go to the left, like this, and maybe we have a continuous function, and maybe it just goes down like that. So it approaches another asymptote on the right-hand side. And just to give some numbers here, we'll say that this is up at 2, and this one is down at negative 4. So when we're writing our limits, we'd say that the limit as x goes to negative infinity of, we'll call this g, is equal to 2. So we would have a horizontal asymptote at y equals 2, or the limit, we have the limit as x goes to positive infinity of g of x. We could say that that's equal to negative 4. Because as we go down, it tapers off and approaches negative 4. So we have a second horizontal asymptote at y equals negative 4. The next thing I want to do is imagine that we have some limits here. So say we have some limits as x goes to infinity, f of x is equal to infinity. Some other conditions, limit as x goes to -2 from the right of f of x. We'll say that is equal to 6. The limit as x goes to -infinity of f of x is equal to 4. The limit as x goes to 2 from the left, or from the left, is equal to infinity. Say I'm given all this information about some unknown function f of x. What does this tell us about asymptotes? How many asymptotes do we have? Well, the first one does not tell us anything about an asymptote because it's going to infinity and it equals infinity. So that does not give us any information. So that gives us none. No asymptotes there. The second one tells us that as we're going to a finite number, we get a finite number. So again, that gives us no information about asymptotes. This one tells us that as we go to -infinity, we are getting a finite number. So that's our definition of a horizontal asymptote. And we say that there's a horizontal asymptote at y equals 4. And the last one here, as we approach some finite number, 2 from the left, we're getting infinity. So that gives us a vertical asymptote. And we say that the vertical asymptote is at x equals 2. Some students might have a difficult time with the horizontal and vertical. So from Algebra 1, I usually tell my students to memorize or use the mnemonic device HOI VUX. HOI stands for horizontal lines have 0 slope, and we write those as y equals some number. Vertical lines have undefined slope, and we write those as x equals some number. So when I have a horizontal line, like I do here, then I know it's going to be y equals that number. And when I have a vertical line, like I do here, then I know it's going to be x equals that number. Next thing I want to do is to actually take some limits of some functions, and we will try to evaluate these both algebraically and with our calculator. Let me just move these. The next thing I want to do is to take some limits and evaluate these both algebraically and use the calculator as a tool. So let's imagine we want to take the limit as x goes to -infinity of 2x squared over x squared plus 9. Now this is a rational function, and when we have rational functions, here's the rule for finding horizontal asymptotes. So horizontal asymptotes, we got some rules. First off, we want to look at the degree. The degree is the highest exponent. Highest power in the polynomial. So, for example, the 2x squared, the highest exponent is 2. For x squared plus 9, the highest exponent is 2. If I had a cubic, it would be degree 3. If I had quartic, it would be degree 4. And linear would be 1. Constant would be 0. So if I want to find horizontal asymptotes, I'm going to look at the degree. If I have a small degree over a big degree, then I'm going to have a horizontal asymptote at y equals 0. So for example, if I had just 1 over x, that has a horizontal asymptote at y equals 0. If I have a big over a small, so the degree on top is bigger than the degree on the bottom, then for horizontal asymptotes, well, I don't have any. I have none. So an example there might be x squared plus x plus 3 over, we'll say x plus 2. So the degree on the top is 2, the degree on the bottom is 1. So since the degree on the top is bigger than the bottom, it doesn't have a horizontal asymptote. And the last thing that can happen is I could have a small, or actually the same over the same. So let me delete that. The next thing I could have is a same degree over the same degree. And in that case, I am going to have a horizontal asymptote. And the horizontal asymptote is going to be A over B, where these guys are the leading coefficients. So they're the leading coefficients. So for example, if I had 4x squared plus 3 over 2x squared plus 7, I would have a horizontal asymptote at y equals 2 because I take 4 divided by 2. So we can use these rules in order to find the limits algebraically. So going back to my example up here, the limit as x goes to negative infinity of 2x squared over x squared, they have the same degree on the top and the bottom. So I look at the leading coefficients. The leading coefficient on top is 2. The leading coefficient on the bottom is 1. It's going to have a horizontal asymptote at y equals 2. We can also do this in our calculator. So if we pull up our calculator and we go to y equals, and just clear this out. So bring up a fraction, type in 2x squared, put that on top, over x squared plus 9, put that on the bottom. We can look at the graph, and the graph is showing a horizontal asymptote on the left side and the right side. It looks like it's going to be 2, but just to make sure, we can check the table. So if I go to second window, I can change my table where it starts and how much it goes up by. So let's go to our table. We want to go to negative infinity. Now I can't type in negative infinity, so I just type in negative and type in 1 with a lot of zeros behind it. And then when I go to second graph and I go to my table, I can see that it's getting pretty close to 2. So that is my horizontal asymptote. Likewise, if I go to the other side, if I want to take the limit as x goes to positive infinity, I would just put in a really big number, like a billion or a trillion or a gazillion. That's not a real number, but you can see that if I go to the table, again, if I go to a really big number, I've got a horizontal asymptote over there. I can see it's going to 2. Let's try another one. So let's say I'm taking the limit as x goes to, this time we're going to go to negative infinity. This time we're going to do something a little bit different. So here I'm going to have a radical x squared plus 2 over 2x minus 3. So I'm taking the limit as x goes to negative infinity. This is a square root of x squared plus 2 over 2x minus 3. Now these rules don't quite apply here because it's not a polynomial over polynomial, but the square root of x squared, that's kind of the same as x, although it's always going to be positive. So keep in mind that this top is always positive, and it kind of acts like x, or at least the absolute value of x. And the bottom here, the leading coefficient there, the leading term is 2x. So it appears that I would have a horizontal asymptote at y equals 1/2. But we have to be careful. We have to check the sign. So if I go to negative infinity, the top is always going to be positive, but if I put negative infinity on the bottom, it's going to be a negative. This function would actually have 2 asymptotes. So if I pull up my calculator again and go to y equals, type it in. On the top I have the square root of x squared plus 2. And if I go to the bottom, I have 2x minus 3. I look at the graph, and I can see on the left side and the right side, it does appear that I have horizontal asymptotes, but they are slightly different. Again, if I go to my table and I put in a very, very small negative number, and then bring up the table, hopefully you can see that. It comes out to about negative 0.5, which is negative 1/2. So we are correct. The limit here would be negative 1/2. Up here, the limit would be 2. I wrote the horizontal asymptotes. I should have just wrote the limit. So the first one, the limit would be 2. It has a horizontal asymptote at y equals 2. Here the limit is negative 1/2, and it's got a horizontal asymptote at negative 1/2. All right, that's all I have for now. So hopefully this helps you out, and we'll take care. We'll see you next time. Bye.